In this video, we're going to discuss whether the sequence converges or diverges. Okay, so the example we're going to be talking about is going to be, the nth term of the sequence defined by n 2 to the power of n divided by the 3 power to the power of n. And notice that we can express it as n multiplied by 2/3 to the power of n, right? Because both 2 and 3, the bases, are raised to the same power, n, okay? And also notice that for convenience we can write it as n divided by 3/2 to the nth power, okay? It's the same thing. Now, notice that if we try to see what the end behavior of the sequence is by taking the limit to infinity, we'll wind up with indeterminate form. Infinity divided by the infinity, right? So we have to do something to it to avoid it, right? So what I would do, I would take the natural logarithm of a subscript n. So I would have ln a subscript n is equal to ln n divided by 3/2 to the nth power. And that would give us, using the properties of logarithms, ln n minus ln 3/2 to the n, and further as ln n minus ln 3n minus ln 2n. And now, using the other properties of natural logarithm, well, any logarithm, we know that the power n can be brought up in front of ln 3. So we will have ln n minus n ln 3 plus, because there's two minuses there, right, plus n ln 2. And now we can have ln n minus, and we can combine the n, factor out the common term n. So we'll have the minus ln 3 minus ln 2 n. So now if we try to take this to the negative infinity, we will see that it's basically going to give us negative infinity. And why negative and not positive? Because notice that for any value of n, you will have a negative result, because this will always be bigger than the first term. Okay? So you will approach negative infinity as you go infinitely, as you enlarge the n infinitely. Okay? So you'll have a negative infinity. So now you're actually almost ready to evaluate the end result, right? To see what the sequence will do at the very end as it approaches, as the nth term is infinity, right? So it's going to be, so we need to calculate the limit of the, as n approaches infinity, of the nth term, which is the same as taking the limit to infinity of e to the power of ln of the nth term. Okay, these are the product, the relationship between the e and ln that you should know as well. Okay, so now, since we already know what ln a subscript n does as n approaches infinity, because we know it approaches negative infinity, so we know that basically we will have e raised to the power of negative infinity, right? We just substitute ln a subscript n with a negative infinity. And as you should know, using the graph, I can show you, e to the negative x is this function, right? So e to the negative x. So as you know, as x increases infinitely, this function will approach 0, right? The x-axis. So that means that the sequence is actually convergent to 0 as x increases infinitely. Okay. Well, you might say, but wait a second. didn't you say negative infinity? Why are you talking about positive infinity? Well, you can interpret it another way. You can think of e to the x and plug in negative infinity for the x there. So that means you will go infinitely negative from right to left, and you will also wind up at the x-axis as you go infinitely to the left. Okay, so it's the same thing. You will still be convergent to 0. Okay, so this sequence is convergent to 0. So I hope this tutorial was helpful. Please subscribe, and I'll see you in my next video.